Let's see how the CNC machined engine cover was produced. CNC machining is a subtractive manufacturing process, so we need to start with a large block of material which will gradually get carved down. However, it's not just a case of loading the material and pressing play. Prior to this stage, there was a fully 10 hours of preparation. This included 4 hours of analyzing the digital files and 6 hours of configuration. While this is taking place, the machines also had to be set up with the correct cutting tools and parameters. This technology can't produce the prototype in a single piece, so 3 separate machines were needed to make different sections of the part, which were then glued together at the end. Here we see the main section of the engine cover. Notice the mountains of waste material piled up at the sides. In contrast to CNC, the SLA printed part is produced in a single print and without any waste. Seeing the complete part emerge from the tank is always incredibly satisfying, and even without post-processing, it already looks really nice. Only a small removable cover was printed separately from the main part, and that was printed at the same time in the same tank, so it didn't lengthen the build or complicate things. After the preparation was done, it really was just a case of press play and go. When we look at the newly milled CNC part, we can see the contrast. The table is covered in all kinds of bits and pieces that had to be cut separately due to the physical limitations of CNC. All of these had to be glued on later. This is because the cutting tool is very limited in its movement and many sections of the engine cover are obstructed during milling. The technician has to refer closely to the original drawings and make sure that everything is assembled correctly. Maximum precision is required at all times. The gluing is a particularly tricky and time-consuming process, and there is inevitably some loss of quality in the finish. Our team is extremely highly skilled, but it's just not possible that a glued-together part can be as smooth and seamless as a part that was printed as a single object. In terms of dimensions, the 2 parts are essentially identical and both took 40 hours to manufacture. However, when you add the 10 hours of preparation time for CNC and the additional gluing time, the total process for CNC is a good bit longer. Crucially, the 3D printer can be operated by just a single person and the entire part is printed at once, while the CNC machines need several people to operate them. It's clear that CNC machining is much more labor-intensive and uses a lot more resources. It's not just prototypes of engine covers that are a perfect fit for SLA printing. Here are some examples of other automotive parts that we have produced for Great Wall. This radiator grille has a very complex structure that would be a nightmare to CNC machine, but is child play for an SLA3D printer. This door section is a similar story. The part was too large to print as a single object, but we were able to do it in just a few sections, all of which could be printed together at the same time. The complex mesh for the speakers was one of the sections printed separately and is another example of a shape CNC machining would really struggle with. The main sections were printed in such a way so as to be easy to join together in post-processing. Although gluing is never ideal, assembly for this 3D printed part was fairly straightforward and the number of sections that needed joining was minimal. Once the gluing was complete, it was just a case of sanding down those areas and working the surface to a smooth finish. Had we had to rely on CNC machining for such a large and complex prototype, costs would have been through the roof. With 3D printing, it was just a regular build except with the addition of